Hey stats students, welcome to Unit 9. We're going to go through section 6.1 to 6.3. And I know it sounds like a lot, but it really isn't. We've got some really important key terms to go through here. The first one being chance experiment, okay? So a chance experiment is just uncertainty about two or more possible outcomes. So like our 3 shots basketball thing that we did, that is a chance experiment. A sample space is a collection of all possible outcomes. Of a chance experiment. So when we did the basketball activity and we listed out like, okay, they can make, miss, all of that, that was listing out our sample space. An event is any collection of outcomes from the sample space. A simple event is one that has only one outcome. Let's say that we have events A and B. The complement means all experimental outcomes that are not an event. Not in an event. So for instance, an example could be not event A. There's some different notation for this, okay? Notation for not A looks like this: A with a little c to mean A complement, or A prime means A complement, or a little squiggly in front, A means A complement also. All right, let's talk about the next one. That's union. Okay, union is our A or B situation. So, sorry. This is all, oh my goodness, all experimental outcomes that are in both events. At least one of the two events. So for this is our or situation. We have something happening in A or B. And the notation for union looks like a little upside down U. This means A or B. Okay, and intersection means A and B. So this is all experimental outcomes that are in both events. So it has to be an A and B, and our, oh my goodness, above I said it needs to be a little upside down U, and then I wrote the wrong one. This is A or B, a little upside down U, and intersections A and B. This is upside down U, this is a regular U. It's late, I guess, jeez. Okay. Disjoint or mutually exclusive events, they mean the same thing, is when events have no common outcomes. All right, let's look at some pretty simple examples. Here's an example of how to list a sample space. So let's say you flip a coin and you roll a regular 6-sided die. What are the possible outcomes? Sometimes when asked to do a sample space, you have to make a chart, a table, a list, or a tree diagram, or some common ones that we're going to use this unit. So we'll just work on this really quick. My outcomes are I could get heads in 1, heads in 2, heads in 3, heads in 4, heads in 5, heads in 6. Or I could get tails 1, tails 2, tails 3, tails 4, tails 5, and tails 6. Those are all possible outcomes. Here's a way to represent that is my first event is that I roll the coin, or I flip the coin and I get heads or tails. And the second event is I roll the die, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And I see all the possible outcomes that I have there by just following that tree diagram. Heads in 1, heads in 2, heads in 3, etc. All right, let's talk about Venn diagrams. We're gonna actually be using these a lot. So I'm gonna zoom in right here. Let's draw a diagram with event A and event B. Okay, so remember, event A, event B, this is where they overlap, what they share in common, and this is the entire sample space, so possibly things existing outside of event A or B. So let's look at A complement. Remember, A complement means not A. So what does that look like when we shade the Venn diagram? It looks like everything but A. I know this is not the most beautiful, I'm sorry. There's A complement. Knowing how to draw and shade a Venn diagram is super important in this section and is definitely something we'll continue to work on. Let's look at what A or B looks like. Here's event A or event B, and here's how you do this. Event A. Just highlighted event A circle. Or event B. And so we've got both of their overlap. A or B means the outcome can be in event A or event B. As long as it's one or the other, it works. A and B now, remember, that is only the outcomes that these things have in common. So it's the intersection. A and B. This is A or B. And the last one is disjoint. What does disjoint look like? This means there are no common outcomes between the two events. They don't overlap at all. They're separate. They have space, okay? A and then B completely separate and far away. All right, let's go to the next page. All right, section 6.2 and 3, definition of probability and basic properties. All right, here are some properties of probability. And we're gonna just talk about an event E. We're gonna reference some event that I'm naming E. Property number 1 is that the probability of this event occurring obviously needs to be between 0 and 1. Remember, probability is a proportion. And that proportion looks like success over total. Number 2, the probability of S, where S is the sample space, is equal to 1 or 100%. So the sample space is 100% all possible outcomes, okay? The probability of E or F is the probability of E plus the probability of F. And the probability of E and the probability of E complement need to add to 1. This is why when we were doing the basketball problem, we were able to say, okay, if Darius Washington's event being a success of making the free throw is 0.72, then his failure of making that free throw is 0.28, because together they equal 100%, okay? These rules that we're talking about right here are for disjoint events, okay? So for disjoint events, when we have events that have no common overlap, if we want to find the probability of one or the other, we just add them together. So down here, at a wedding, 50% of the people order steak, 20% chicken, 15% fish, and 15% vegetarian. What's the probability the next dish served is chicken or fish? I want to know the probability of chicken or fish. So this is just the probability of chicken plus the probability of fish, because these are two disjoint events. So this is just the sum of the probabilities of individual events, because I can only pick one. Getting two dishes is not an option at this wedding. So 35% chance. Okay, let's talk about experimental probabilities. So experimental probabilities are what actually occurs when we try something, or what we observe. These are observed outcomes. And the probability of that event, remember, is the number of whatever we just deem a success over the total. So let's look over here. Scarlett decides to count the number of M&Ms in a small bag. Given the data below, what is the probability of getting of randomly pulling brown M&M blindly? All right. So a success in this case would be a brown M&M. And so for an experimental probability where we're actually going and doing something, we'd take the total number of M&Ms, which when I add these up, it's 168. And a success is deemed getting a brown. So the probability of brown is 28 out of 161. Out of 168. Oh my gosh, you guys. I should not be making this video so late. 16.7%. Okay, last thing. Theoretical probabilities are different than experimental probabilities. Experimental probabilities are we have the counts, we saw something happen, or we carried it out ourselves. Theoretical probabilities are what we expect to happen. So it's something that we have to kind of map out. Like, in theory, this is what should happen. So over here, when we're looking at theoretical probabilities, we're mapping outcomes here. We're making predictions, okay? We're going to probably use a tree or a Venn diagram or a chart or a list. Something needs to happen because we don't actually see the outcomes. We have to kind of make them ourselves. So for instance, you are playing Dungeons and Dragons. To survive your turn, you need to roll above a 12 on a 20-sided die. What is the probability you do not survive your turn? Okay, so obviously we're not looking at data of like someone actually rolling the die where we have the experimental probabilities. We're talking about something theoretical, something that could happen. So I talk about what can happen, and I can roll 13, 14, 15, 16, 17, 18, 19, or 20. So remember, event A is you survive your turn. So the probability of that not happening is 12 out of 20, or you could write it the other way. Also, the probability of event B or whatever, event A is that you die, and it's 12 over 20 still, and that's 0.60. So today we just have some basic definitions. Theoretical probability, things that we expect to happen. We don't have the actual outcomes, we have to map them out. Experimental probabilities, we have the outcomes provided to us. We just look at some proportions based off of success and total. If you have two disjoint events and you want to know the union of them, the or situation, if there's only an option of one or the other, just add their probabilities together. And don't forget about our 4 little rules up here. For any simple event, or any event, not a simple event, just any event, the probability of that event occurring needs to be between 0 and 1. All outcomes add to 100%. If it's disjoint, we just add the probabilities of 2 events together. And the complement and the regular probability always add to 1. All right, you have a little bit of homework listing out some sample spaces and stuff, and we'll go over it tomorrow. Bye.